Hello. It seems that I have managed to get the senior review done after all. Hello and welcome. I am not going to go through question one again because question one was from the junior paper. And some of you, while waiting for this, have already watched the junior review video. So I'm sure you've seen that that's question five of the junior paper. And therefore, I will not be going through that here so as to not prolong this video unnecessarily. So instead of going through question one, I will just say a little bit about the postmortem. I'm recording this obviously later than the junior round two one because well senior is harder. And yeah, I was there to say hi to some of you after the round two, and as I remarked to some of you also, yeah, everyone was disappearing pretty fast because it was usually the response to did not go very well. Otherwise, there will be lots of people triumphantly declaring stuff, right? So I would say that at least the junior question is a normal question. So by normal question, I mean that it was not Vieta jumping or something weird, but it was also not too trivial that like you can do it in like 2 minutes, So I think it's a fair question. It's good they brought it over. So that question, most of you can also tell it is junior, right? It is clearly different from the rest. Now, as for the rest of the questions, just to say straight up, question two is really hard. I think very few of you would have solved it. It's hard to solve properly and it's hard to bash. It is quite certainly one of the hardest, if not the hardest ever geometry question in the senior round two. I think I can say that quite confidently. Of the remaining questions, 3, 4, and 5, I said, why is it GGAAC? So you have got a FE, you have got inequality, two algebras, and then combi. No number theory, apparently. I think that between 3, 4, and 5, question 4 is likely to be the easier one because there are multiple pathways to it, one of which we will say later. And so therefore my sensing is that you would need two questions for a gold, two questions plus maybe a bit more than the bare minimum round one score. So if you have 2 questions and a half and a good round, sorry, 2 questions and a half and a bare minimum round one score, you also can be very confident of a gold. And I don't think top 30 is that far away. But the thing is that I don't really know how they are going to give partials for, let's say, question 2. I don't know how they're going to give partials for question 3. And I also don't know how they're giving partials or answer marks for question 5. So I would say that 2 questions is definitely enough for a gold. It is not absolutely necessary, perhaps. I also say that 2 questions may also be the sort of 2 questions and like 2.5 maybe, and a good round one score can be enough for a top 30 quite comfortably, right? Because it is very hard to have gone beyond 3 questions for this paper. Now, that is from the sample size of whoever I managed to catch and speak to this afternoon after the round two. So you can vehemently disagree in the comment section. Right? We are just going to leave question one. We are going to go through the other 4 questions. And we are actually starting with, I think, also the hardest question of the paper, if we're being honest, which is Q2. It's like a second geom, but Q1 is not really the traditional geom. So it's like really this is the geom question. And I think we are all pretty happy with the drawing until you get this very weird condition. So let's try to draw it large, as many of you already have seen that if you don't draw it big enough, things don't go well. Why did I not draw the in circle first? I always say draw the circle first. Okay, draw the circle first, and then draw a big enough triangle. Your triangle should not look too much like the tangent is at the midpoint. So that means that I will try to make sure that it doesn't look too isosceles, otherwise that may be a little bit misleading. But you can't really prevent some degree of like two sides looking a bit close to each other. Okay, so I'll try this first. This is just an attempt at it not being isosceles. We know that drawing this is really hard, right? So there is the in-center I. You have got your I x and iy and ad are supposed to be tangent to the circumcircle of axy. So it is, as we can tell, not difficult to get AD to be tangent, but if let's say that I am trying to draw a tangent and it's like this, then obviously Ix and Iy would not be very tangent to that circle. So it must be a flatter circle. If let's say that your circle looks something like this, then it may be plausible. So you just make it as narrow as you can, and then we can sort of just also realize that, oh, but I need the thing to go through the midpoint of BC. So if I want it to go through the midpoint, but the thing is that like it's very close to just being this line. Yeah, so if it's very close to just being that line, I don't want it to be that line. I am just going to like, tweak my x and y a little bit. Now this was, as many of you have noted, something where it's a bit difficult to draw. So I'm going to just make it such that like, but this also kind of motivates what I want to do. Actually, no, I can't have it like that. So I need to at least make sure that AXY is acute. So maybe I will just, maybe my eye is also off a little bit. So I'll just move my X and Y to where I want, and then I'll cheat a little bit with the in-centers location, because maybe that's the better place to cheat. So so I think we can live with this. It's very narrow. But like I said, it will inform my approach to this, because I feel like as if there may be things that I can observe in this diagram, but I really, really do not want to rely on that, because there's no way my diagram is accurate, and honestly, there's no way yours is either. So I am going to try to use as many high-level geometric properties as I can. And so that's why I say it's the hardest question. Maybe there is a low-powered way, but a low-powered way requires some observations which realistically you cannot make because the diagram is too hard to draw. So I'm going to make a few of them. Now, the first thing is that I will define M to be the midpoint, not to be on the line, because I know that xy is the radical axis of omega and of that circle axy. They both go through xy, so the in circle and that impossible to draw circumcircle both go through xy, meaning that that is a radical axis. So therefore, if I want to show that M lies on it, I want the power of the point M to be the same with respect to both circles. Oh yeah, I will, in fact I have, by the time you're seeing this, typed out a set of readable solutions that are in the description below. So you can download that if you want to see how it could be written out. Right here, I'm just going to talk about how we solve it, and my focus is more on the figuring out phase than the, how am I supposed to explain it, or how am I supposed to draw the diagram for the matter. Okay, so the power with respect to omega of M, I know, is equal to md squared. So therefore, I want the power of omega, sorry, right, this is the wrong direction. The power of M with respect to circle AXY to also be the same. Now, it is a little bit tricky to know what is the power of m with respect to axy when I don't yet know that m is on the line xy. So we will hold that thought. Under normal circumstances, what I would want to do is to put the circumcenter, I mean, and then talk about that. But the circumcenter is going to be like somewhere probably off the page, so I'm not going to put the circumcenter. It's just not a very good idea. Now, the next thing I would say is that this also fits into one of our well-known lemmas, which I have mentioned if you are in my class, and also if you have read, let's say, EGM or any of the go-to geometry lemma references. The fact that if you were to draw the line through the top of the in circle. In other words, if you say draw through the top of the in circle, meaning that this is the diameter, it will hit a point here, which is the x touch point, where the x circle touches. It's also going to guarantee that BD equals to CF, and therefore DM equals to MF. And so when you see a midpoint in circle, and this in touch point is named, this is something we do. Right? So I'll just give it names. Right? I'll call this point here just E. I just said there's F because in my notes I call it E. So let DE be a diameter of the in circle. Then AE intersect BC equals to F. Then DM equals to MF. Okay, so this is how I have chosen to, in some sense, relate the midpoint some more to all of this. Now, why is it that you might say that's not very impressive? Like, what is the reason why you're doing this? The reason why normally when you see the in circle and the in touch point and the midpoint, you do this is that this is creating the midpoint here, but it is also true that I is already the midpoint of DE. So that means that by your midpoint theorem, you have found something about M. IM is parallel to this EF, which is the line AF. So congratulations to us. At least this M is doing something. But it's still not doing that much, right? I am still a little bit stuck with all the things down here. Well, the good news is I haven't actually used any of the information that is special. So this is something that I can do as long as I have any triangle and the point D and the point M, and then there is an in circle that's supposed to matter. I can do this for any such figure. But the special condition, which I'm sure this question is set up that way, meaning that this is a default construction. This is the special thing, right? The thing that made it so hard to draw. Now, in a way though, they said IX, IY, and AD. You do realize that it is a little bit redundant to mention both things. It's a bit redundant to mention both things because of the fact that your if Ix is a tangent, and then Iy would also be a tangent line because they have the same length. So it's more like I have to use two tangents in a way than three tangents. Right? So if that helps us to narrow down our search. Now, also, we are trying to use lengths because I don't want to depend on the drawing too much. It's impossible to draw. And I can't really tell what is the use of, let's say, IM. Remember, Y is not on IM, right? Y is just some other point. IM being parallel to this. I found it. What I'm going to do is I'm just going to extend it out, because this would then be the midpoint of AD. Let's call this N. You can always, of course, say that this is parallel, but usually you may extend it to different places. You may not want to extend it to here, but AD is not even going to always be drawn. So like, it makes sense to try to put this there, since AD is something that is useful. It is a tangent line. So maybe I can say something about my power of a point somehow if I have now a midpoint that is related. And so I'm happy to accept that. Now, the last step, and yeah, believe it or not, this is already at the last step. The last step is something that I think is not something that's been used in the SMO before. It has been used in some contests in the US, China, and all. So is that because of the fact that I have now got M to be on the line, and M is still the least useful point in itself. The main useful feature it has is that it is on a line. I would like to maybe say that I can calculate or say something about the power of the point M based on the fact it's on a line, and MD squared would be related also to the power of the point M with respect to a circle centered at D. Now, what circle is that? Well, I don't know, but I do realize that if my N is now related to D, my I is related to D, and I want M to be related to D, they're all in the same ballpark. So I can say with my tangent lines, remember that I, X, I, Y are tangent, I just use one of them. I can say that IY is equal to ID N NA equals to ND. Both of these are tangents. Now, this implies that if I look at them as squares, they are powers of the point I and N. They are powers with respect to the AXY. But if that's the power of I and power of N, this also is a square. That's also related to the power of I and N with respect to a circle centered at D, which is a circle. There is a point. So to make it clear, I'm going to just let just gamma be the circle centered at D with radius 0. So I'm just saying this to distinguish, but basically it's just the point. So if it's centered at D with radius 0, then that would be defined as the power of a point, because it would be distance squared minus radius squared, which is otherwise 0. And so therefore, it is the power of I with respect to gamma. It is the power of n with respect to gamma. And that implies that your In is the radical axis of gamma and axy, where m lies on it. So that means that we are actually done. I say straight up that this is the hardest question, I believe. The only reason why this would make sense to me is that, well, the general approach I'm taking is to try not to angle chase anything because I have no space to mark any angles. You could try, and I'm sure you did, it is really hard. So I'm trying to use high-level approaches. The approach of relating the in touch point and the midpoint when you have an in circle is that lemma, which is fairly common. And then because I found a line that M lies on, where a lot of it is related to tangents, and I have seen this idea of having a point circle before. So it makes sense to me. You can even use this idea for, let's say, radical centers. Two normal circles and one point have a radical center, and you get quite interesting results from that. So it is just something that's never been used in the SMO before. So I suppose this is the first time. In fact, it's the first time in a long time that the geom question, that exists a difficult geom question in the senior round 2. Okay, everything after this is going to be easier. So the next one is question 3. Functions from positive integer to positive integer with this fmn plus n equals fmn plus fn. I'm sure that if you clarify with the invigilators, they would have confirmed to you that this is not a power, this is just iterated, right? So f to the m of n is f applied m iterations of f to n. So this is what the notation meant. The first thing that I look at this is that, yeah, I know that fn equals to n works. That is very evident. I don't immediately see anything else that works. So I then realized, oh, if fm equals to m, then that will cancel off, right? So which means that if, let's say, fm equals to m for some m, then you'll get fn equals n for all n. So in other words, if I think I'm going to prove fn equals to n, one value will give everything. But then when you substitute, you're not even going to get one value, right? You're not even going to find f of 1. So I can't do that. However, I can show, just based on this, another very obvious feature is the injective feature, because there's just one n that is exposed. So let's say I can say that f is injective. But that doesn't also do anything yet, because I don't really know how that is going to lock this in either. So this is the initial observations that I had. One value is enough to make everything n, and then the f is injective. Now, all of it is also that n is the subject of your function, the input into the function. In other words, it is kind of like this is talking about the chain of when you apply f many times to the same n. And it is talking about a relationship between two pairs of things in this sequence, but not two fixed pairs, right? That means that there are many ways in which two pairs in this sequence have the same sum, according to this, right? The first, the zeroth term, as it will, the mth term, the first term, and the fmth term, these are the two pairs. But two of them are not moving. And so I can write this, and this is basically where the action starts to happen. I can write at least the two fixed ones on one side and say that, okay, that means that whatever this gap is, this gap is going to happen infinitely many times, right? So the gap maybe is here, is the same gap. Here is maybe the same gap. Is there anything unusual about that? No. If let's say this thing here is going to be +1, then maybe there are many times where something is one more than the other. Nothing wrong. If let's say that this is going to be -1, there are also many times where something here is going to be one less than the other. So again, it seems there's no issue. But there is an issue. Because if we think carefully, and this is a thing that makes positive integer different from just integer. You notice that they didn't have to mention that n is positive, right? You could have allowed this to be an integer to integer function, just that m and fm are positive, not that n is positive. So the positive usually means that you can make this kind of argument about infinitely descending chains. Basically, if you just replace m by fm, you get this. If you replace it by fm again, you get this, and so on, which means that you have found yourself an arithmetic progression. This is constant for fixed n. So it means that this is an AP, and for APs in positive integers, it cannot be decreasing. So the common difference has to be positive. Now could it be 0? Well, we have already said that it is, if one of them is 0, means fn equals to n, then everything is going to equal. So suppose, I guess, otherwise, that fn is not equal to n for all n, I can put that condition down. So based on that, now when I look at this, I can say that the sequence here must be increasing. Is there anything wrong with it being increasing? Not really. I mean that your m, fm, ffm. Now if I say that fn is more than n for all n, then, I mean, you apply f, it just keeps getting bigger. So means you apply f more times, this gets bigger. Like, I don't see anything clearly wrong with this. And why I'm looking for something wrong is that I'm trying to just get a contradiction, right? I think that it's only fn equals to n. But I don't see anything wrong with this right now. Here's something else that I noticed. Now, I noticed that, so I've deduced that, oh, actually this one just keeps on increasing, right? So actually this is getting larger and larger and larger as you go all the way down. But this is a big gap. And so if it is increasing, that means that this whole sequence is increasing, then I can conclude that this must be a lot. Right? So if I can conclude that this must be a lot, because these are, you have applied f many times more, right? From fm to m, then would I not get some contradiction that it just goes to infinity? So I want to check that. And I think that since I'm looking at like how many times it has increased, that's talking about the difference, I will let gn equals to fn minus n. So that this thing here can be described as just, the sum of the differences. Fn minus n allows me to talk about the difference between consecutive things, because this would be Gn, this would sound like be G of Fn in a way, and so on. So based on all of this, f of m, apply fm times to n rather, minus f apply n times n equals to fn minus n can be also written as g of m until g of, no, that's not quite right. That is actually nestled inside, right? So let me rewrite that. That is g of fmn, fm plus 1n all the way to f of fm minus 1 of n. So this is going to be the thing that is equal to, well, just g of n. You observe that again, because I know that this is strictly positive and I'm working in positive integers, the left hand side has how many terms? You went from here to here. It's basically fm minus m steps apart, right? So fm minus m steps apart is the number of increases. So that's g of m terms. And that number of terms, each of them is at least 1, which implies that the left hand side is at least g of m. And so your g of n has to be at least g of m. But what are n and m? Anything. So that tells you it's constant. If anything is greater than or equal to anything else, and that also applies in the reverse direction, then clearly g is constant. And so if g is constant, then you just let fn equals to n plus c. We expect that only c equals to 0 works. But it turns out, surprise, surprise, c equals to 1 also works. You put it in, and you get a bit of surprise solution. Maybe some of you saw it all along. For me, I didn't see it at first. I was like, yeah, oh, that also works. And I was like, oh yeah, it works. So that was a surprise to me, that if you were to take this f of fmn, you basically have got n plus this many c's is going to be equal to n plus this many c's, n plus c, and this will simplify to c squared equals to c. And therefore c equals to 0 or 1, which is to say that there are actually two cases, fn equals to n or n plus 1. Now, a quick clarifying note is that for here, f of n is n or n plus 1. There's no pointwise trap issue, because I've said g is constant. So it's not c is sometimes 0, sometimes 1, no such thing, because g is constant. However, if let's say that you missed out n plus 1, with all the correct logic, I think you just lose 1 or 2 points. However, if you missed out n plus 1 and you have missing logic or incorrect logic, then that would hurt a lot more. Okay, so this is our solution. I'm sure there's more than one way to do it, but when I first saw this question, this is just the approach that I took, apart from the injective thing which turned out to be irrelevant. Everything just sort of flowed quite naturally, because I realized that they all are talking about differences in a chain. So I'm trying to squeeze that as much as I can to get some information. Okay, question 4. You have got this notation with a hat, which may remind you of one of the older senior questions, but that was an NT question, right? Pretty different. This is not saying something that complicated, right? It's just saying the sum excluding one of those terms, and then you take the average, which means that, for example, if n equals to 2, it's just a1 plus a2 over 2 is greater than half a1. Okay, there's nothing there. For n equals to 3, it is a1 plus a2 plus a3 over 3 squared greater than or equals to 1/3 a1 a2 plus a1 a3 plus a2 a3. This is pretty well known. I would say you just clear all the trees and it is by Cauchy-Schwarz or just by AMGM completing the square, anything. For n equals to 4, it's where I guess it starts to be a bit interesting. And I moved around here and there, but it just ended up being the case that I kept on just hitting one so-called high-powered inequality after another that can be used. There wasn't really a super obvious way to use AMGM or like that sort. And the reason why is that you may observe that this is actually equal to, if I just factored out, this is the geometric mean to the power of n, and then this, if you were to say this is just n over the harmonic mean, which cancels, and so this is actually just the geometric mean over the harmonic mean. And so when I tried to, let's say, use the AMGM, I get this AM to the n minus 1 times HM is greater than or equals to GM to the n. Feels like it should probably be true. You have got sort of n minus 1 of the bigger thing and only one smaller thing. But needless to say, it means that just using a naive AMGM HM is not going to work because there is a harmonic mean that is smaller. So that is not going to instantly resolve only using that tool. Now, I also kind of realized to myself that this expression has a name, at least up to a constant. Because all of these kinds of sums, the stuff that you see in Vietas, are symmetric polynomials. And the symmetric polynomials, when we have got positives, they actually satisfy what is known as Newton's inequality. So I'll say the high-powered but less common tools that came to mind. Newton's inequality is just defined as if, let's say that with n variables, sk is just going to be the symmetric sum of all the, I should just say the sum of all the k variable products over n through k. So it's just the average of all of those things, which is basically what is happening here. S1, therefore, is your arithmetic mean, and this thing here is Sn minus 1. So I realized that what you have, the statement, so this is by definition what it is. I realized that this is the inequality you want. And I felt like I've seen this before. What I remembered was Newton's inequality, which tells you that basically your sums are just going to be increasing. Sorry, your ratios are going to be increasing of the symmetric sums. This would be enough to show it. And in fact, the statement we have is that special case, or rather the extreme ends of Maclaurin's inequality. Now, Maclaurin's inequality, not the same guy as the Maclaurin series, but obviously a different statement, is a consequence of Newton's inequality and says basically this, which you can show using this. And certainly this would just be at like the two ends of Maclaurin's inequality. Now, I'm not sure whether if you just said this is Maclaurin's inequality, I don't believe they can fault you. I am not sure, although it is possible, whether any one of the 100 over people who took round 2 actually mentioned Maclaurin's inequality. If you did, you can say in the comments. I have no idea whether that would have been considered as a valid solution to just say this is a special case of Maclaurin's inequality. I would, however, say that it would definitely be worth most of the marks, even if they are not willing to give 10, they can't deduct much because you have validly identified the name of the inequality. The much more common approach, however, that many of you would have identified is just Merhead. Now, the reason why you identify Merhead is just that this is the smallest possible degree n-1 combination of n variables. So you can't really have better than that. What that would mean is that the left side has a lot of things that majorize the right hand side, and the weakest thing on the left hand side just looks like that. Merhead will work, we just need to decide how we are going to show it, and perhaps I'm not going to use the right side, I'll just write it below. How do we use Merhead in this situation? Okay, so first of all, I will just write down the general statement now. From the fractions, I'll just get rid of them first. And then from the perspective of Merhead, this is viable because everything is clearly a symmetric sum. If you are not so familiar with Merhead, I'm not going to explain it in this video specifically. You can just go and check it out. But basically, for each of these symmetric sums, you can write it as just an expression in terms of its powers. But just like the normalizing for your symmetric polynomials for Newton and Maclaurin. Okay, so I'll just the symmetric sum is supposed to have n factorial things. So if there's n things only, that means that it's actually n over n factorial of that. Right? Because if you were to actually permute all the variables, then each of them would have appeared, n minus 1 factorial times. Anyway, on the left side, I don't really want to write out the full Merhead notation. However, I can just describe it. Now, what I can describe it is that the left-hand side is actually the sum of constant times, let's say, a1, a2 to an in your Merhead notation, where each of these, first of all, are non-negative. They are integers. And they sum to n minus 1. Now that already implies that the last one is 0, which is of course true. We can see that there would not be n different variables in our expansion. And also it implies that if you were to take any of the initial chains of it, a1 to ak is going to be greater than or equal to k over n minus 1 of the sum, which is k. And so that means that it majorizes this bunch of ones and zero. Integer is not needed for the statement of majorization. It is required just, just so that we can say that the last thing is zero, and then we don't have the second last thing to be half, or and the last one be half. It is, even if we don't say, it's fine. So this majorizes, and the second thing is that what is this constant C? Well, the sum of all the C's is just the sum of all the coefficients that you expand. Divided by n factorial. And the sum of coefficients is what happens when you sub in x1 to xn equals to 1. That would be n to the n minus 1 over n factorial. Right? So therefore, if you were to just take the left-hand side, times this is greater than or equals to basically the sum of these constants. They're not fixed constants, so I can write it like this. All of them are greater than or equals to this by Merhead. And then the sum is this. Which is just what that's equal to. Yeah, so I think if you're using Merhead, you would just like to explain why every combination majorizes it and why the thing actually matches. You do not need to state when equality holds. Obviously, we know when equality holds is when everything is the same, but we do not need to state it because the question doesn't ask for that. Yeah, so I think Merhead is something that's much more mainstream for us, especially SMO senior and open level compared to Newton's and Maclaurin's inequalities. So I think Merhead is fair game for something like senior. Now, technically speaking, Merhead is always just an application of weighted AMGM. So there will exist some weights that will allow you to use AMGM, but I think it's a little bit difficult to explain where are those weights, and it is not necessary to. Merhead is, at this point, it is quotable. It is accepted. All right, that brings us to Q5. Now, Q5, this is a question where I did a bit of a check because I'm sure I had seen this question before, not with the number 8, but I'm sure I've seen this before. And then when I did a search, it's literally my search history about isosceles triangle in a polygon. I cannot remember. I feel like one of you asked me a question about this before, and I cannot remember who and when. But it was in my search history, and there's an OEIS sequence, which is this A341584. The OEI sequence is basically well, you can call it a sequence. So like the AN is the maximum number of vertices from regular n-gon without any isosceles triangle. Why am I mentioning this? I'm mentioning this not because, so if I had known that, no, I'm mentioning this that actually AN has no closed form. AM has no closed form, meaning that there is no expression in terms of n. Now, of course, our question is basically what is the smallest m such that AM is at least 8 if we view it from the perspective of the OEIS sequence. There is no actual property. It's not even monotone. I'm basically trying to be defensive here about what I'm going to do next because I'm saying that if you're thinking that there must be a less, bashy way or a less caseworky way. First of all, you didn't take junior, so you don't have that many cases already. You should be thankful that not every question in senior is cases. But the other thing is that we can't avoid some cases because it's not monotone. Right? They do actually go up and down, up and down. So the number of sides is very specifically important. Okay. Now, what did I view this as? I view it as like it is just points around a circle. I don't need the polygon, right? It's just evenly spaced points around a circle, which I just number 0 to m minus 1. If I were to have an isosceles triangle somewhere, it basically means that if two things are equal, and this is, let's say, x, y, and z, it means z minus y equals to y minus x, or rather, it's congruent mod m, right? This is the condition for isosceles to happen. In other words, x, y, z is an AP mod m. This made me think of a question which is also in my lesson notes regularly. And this is how it sort of like will tend to be the case for many of us, right? Obviously, you don't have lesson notes from me necessarily, but whatever resources you have, for Combi, it's useful to fall back on stuff that we find familiar, even if they're not exactly the same question. So the question I had was from IMO 1983. Right, can we pick 1983 numbers from 1 to I think 100,000 without a 3-term AP? Now I'm about to spoil you a IMO question from 42 years ago, so I hope you are not too disappointed. The idea is that it is yes, and the algorithm is just greedy. It is just a greedy algorithm where you just pick, let's say I can pick 1, I can pick 2, then I cannot pick 3, I pick 4, and then I pick 5, and then now I cannot pick 6 because of 4, 5, 6. I cannot pick 7 because of 1, 4, 7. I cannot pick 8 because of 2, 5, 8. I cannot pick 9 because of 1, 5, 9. The next one I can pick is 10. And it turns out that if you were to shift this down by 1, these are binary ternary numbers, which means that in base 3, they are like this, which means they are the sum of non-repeating powers of 3, basically. Don't worry, that is absolutely not needed to solve this question. I'm just saying all of this to say that that's why this question is very, very fresh in my mind. And because I know that this is something you can do by greedy, it happens that the next one that comes after this is 27. Right? It'll be 1000. And therefore, I'm sure that 8 was chosen for a good reason, and it's entirely possible that the question proposer was aware of this same IMO problem and therefore knew that, yeah, you can sort of take a power of 2 as the endpoint. So I will use that as the construction. Right? I will now, when I was outside the venue saying hi to some of you, basically some of you say it is 18. So I mean, you say the answer is 18, right? So it's like, I mean, I cannot pretend I didn't hear it, but if I were to say how to construct, because no one yelled to me how to construct, right? I'll try this anyway and say that, okay, so let's try picking 0, 1, 3, 4, 9, 10, 12, 13. But this can be mod 14? No, mod 14, then 1301 will basically be an AP. Then how about mod 15? Then I check, right? Mod 15, it would be basically that I'm looking for APs that go around the loop because I have modulo issues here, which I didn't have there. So it's like, in this case here, I found, oh, okay, so if it's mod 15, then actually this is negative 3, 0, 3. If it is mod 16, right, and then now this would be negative 3. If it is mod 17, then this is negative 4. And then for mod 18, nothing goes wrong. Basically my construction, which is just greedy, to avoid APs without worrying about it being in a modulo sense, gave me a construction which works at 18. Now, this is not to say that works at 18 implies that I know 18 was even the correct answer, if not for the fact that some of you yelled it out. However, I think that if we were to try to construct, trying to construct it greedily does make sense anyway. And finding the first place where the greedy thing works also makes sense. So like, this is like a very realistic kind of thing to check. So let's say that now we have got this value down here, 18, tentatively. I want to try to prove it. I realize that also 18 is 9 times 2. And so as it is, there is this symmetry here, but mod 18, there's sort of a double symmetry, which is that this 0, 1, 3, 4, and then 9, 10, 12, 13. I mean, you can see the symmetry, right? It's that each of them are like 9 apart. In fact, that just means that if you were to actually look at them, they are diametrically opposite each other on the polygon slash circle. So I did not actually, when looking at this IMO problem, check whether it is the greedy construction is optimal, because the question is can you, and the answer is you can, and then you just prove that this construction actually works, which you can think about how it works in the general case where it's very big. But for what I know, I don't know it's optimal, but it feels that it may be optimal, and that could imply that I can look at this half here and say that this half basically gave me I need 9 in order to fit 4 things, even just in a line, without the modulo cyclic issue. Maybe I need this much space just to fit in the first 5 numbers. And by first 5 numbers means the first 4 gaps need to be at least 9. If that were at least 9 and this were at least 9, then that will show it's 18. So therefore, it is reasonable for me to try to look at half of the circle and see if I can bound it. So I will just let the vertices be V1 to V8, and then I will just also look at these intervals and call them like D1 to D8, where the final interval can be taken as make it positive, right? It's just how many steps are they. So I think I'll write it as this properly, so that I have names for them. And then D8 is basically V1 minus V8 plus M. Right? Don't say 18, don't know yet that it's 18. Of course, by this setting, the sum of all of this, which is the total distance, is just the length of one loop around the circle, which is M steps. And so I want to lower bound the sum of the D's. And to lower bound the sum of the D's, I want to see if I can lower bound D1 plus D2 plus D3 plus D4. So that's what I want to do. I hope that actually I can just show that it's 9. And that feels like you can do some casework. Okay. Now, before I do anything, what is the condition that I'm looking for? I'm looking for this AP here, and almost in a weird way, similar to Q3 and the discussion about the difference being a sum of many differences. I can use the same reasoning here to say that I'm basically making sure that blocks of these and blocks of these don't have the same sum. Unless it loops back around, which was the case of like D1, 2, 3, 4, D5, 6, 7, 8. Of course, this sum and this sum is okay because it is coming back. That's not a triangle. That is a line. So I will say that to put D1, D2, D3, D4, can it be any two are repeated next to each other? No. Alright, so D1 and D2 is at least 3, D3 and D4 is at least 3, and they're not the same. Which means that the sum is at least 7. Okay, so if the sum is at least 7, then I try lah, because 7 is basically from 3 and 4 or vice versa. So then there will be 8. Eight would have to be 3 and 5 or vice versa, because 4 and 4 is not allowed. So I just try and see whether it goes well or it does not. I hope it doesn't go well. I hope there's no way, and I can just check, right? So if it's 3 and 4, it means that it's just 1 and 2, 1 and 3. So 1, 2, 1, 3, 1, 2, 3, 1, 2, 1, 1, 3, 2, 1, 3, 1. This one has a pair of 1s. I see 1, 2, 3. I see another 1, 2, 3. I see another 1, 2, 3. Okay, no. So this one clearly fails. Then I've got 3 and 5. So okay, so if let's say that this is 1, 2, this one can be 1, 4, or it can be 2, 3. No surprise that the 1, 2, 2, 3 is going to fail again for the same reason, right? You're going to keep on getting 1, 2, 3 in a row. So that one doesn't work. But surprisingly, actually, there can be something that works with 1, 2, 1, 4. So all of these failed. But if I take 1, 2, 4, 1, again, without the cyclic constraint, nothing goes wrong. So 1, 2, 4, 1, you can check every single difference, no issue. So all I could say is I have to stop here. I can't really say it's 9. I can only say that it's at least 8. So am I sure that actually it is optimal? Okay, to complete this statement first is that, okay, the other thing you can have 2, 1, 4, 1, that's also fine. And then you can, of course, reverse it back as well. 1, 4, 1, 2, 1, 4, 2, 1, you can reverse those. So these are the ways that you can have 4 differences sum to 8. Okay, now I can't again pretend that I did not know the answer was 18 because I heard it. But if let's say that we did not know that it is 18 for sure, what we have currently deduced is that it will be at least 8, and so therefore if it's at least 8, m is at least 16. So, I mean, it will make sense to say that let me just try to make 16 happen. If I try to make 16 happen, it means that I must have the first 4 and the last 4 are these things, and I have to try to glue them together. Well, that's quite hard, because if both ends are 1, then I am in trouble. And if let's say it is 1, 4, 1, 2, and then the 2, 1, 4, 1. Okay, so they're reverse of each other. Basically, just can I do 1, 4, 1, 2, 1, 4, 1, 2? The answer is no, because of the fact that it is just repeating. And you realize that, oh yeah, I mean, I can't have repeated anyway. It can't be 8 plus 8. So actually, not 16, 17, right? Because I can't repeat. The first 4 and the last 4 cannot be the same. Actually, the first 1 and the last 4 can be the same, right? Oh yeah. Okay, so I do need to actually not talk about the repeating. I can just talk about the fact that if you put it like that, then 1, 2, 1 sums up to the same as the 4. Yeah, okay, so that is actually a more correct way of saying it. That if you were to use m equals to 16, then both halves have to be 8, and you can see that there's only one way they can click together, but then 1, 2, 1, 4 will be the thing that fails. Okay, so then after that, we have to write 17 down. For m equals to 17, it means that one side is 8, one side is 9. I could go into cases, because I just also can check that, okay, if the other half is 9, so one half sums to 8, and the other half sums to 9. I could do that, but I don't want to write again all that many cases, I realized that this actually applies to any halves, because it's not just the first four and last four, right? I could take, let's say, 3, 4, 5, 6, and then 7, 8, 1, 2. Both of them must also be 8 and 9. And so if let's say that I know this, then when I have, let's say, 1, 4, 1, 2, and I want to extend it, I know that this must sum up to, well, not this, sorry. This must sum up to 8 or 9. And if I put a 1, then I get the same issue, 4, 1, 2, 1. If I put a 2, then I have 2 consecutive 2s that also doesn't work. So I can't extend this. And by the same logic, if you were to just check the others, like let's say 1, 4, 2, 1, same thing. I can't extend a 1 or 2 out from here, and so there is no way to continue from there either. Okay, so this will imply that 17 doesn't work, and if 17 doesn't work, and 16 doesn't work, and I have a construction for 18, then I am done. Okay, so to reiterate again, this is a paper that's a bit odd because of the fact that question 2 to me is definitely the hardest question, and it is also a paper where it was a bit imbalanced, right? 2 geoms and 2 algebras is quite unusual. Nonetheless, it is going to be your opinion whether it's easy or hard, depending on what your target was. If you're hoping to do all the questions, it's definitely hard because there is not enough time, I think, to do everything. Especially if you don't have the benefit of, for the geom, I could use a bit of software to get the diagram to look a bit more readable for myself. At the same time, if let's say you're just hoping to do like 1 or 2 questions, I think that the question 1 was a really normal junior question that came over, and being able to do one of the questions 3, 4, or 5 is quite realistic. So from that perspective, it is easier than some of the really difficult years like 2022 and 2023. Okay, so I'm not going to blabber on for long. If you have any comments, any questions, if you have anything you want to complain about the SMS and any weird thing that I don't know about in the lecture theatre that happened, feel free to leave it in the comments below. I've included the problems and solutions in the description also, so you can refer to that for a more nicely written up explanation. Okay, and finally, all the best to everyone that is also taking the open round 2 exactly 1 week from now. Okay, so bye bye and see you soon.